Welcome to this lesson. The topic is electricity, and this is another example that is following the previous lessons where we did calculations involving series and parallel connection of resistors. Here we are going to also do almost the same thing. The question reads the PD across, calculate the PD across the 3 ohm resistor if the internal resistance is 1 ohm. If the internal resistance is 1 ohm, so we are going to see that the EMF of the battery is V0 and it's 8 volts. So if the long terminal here is positive, it gives current here which goes through the internal resistance, and then that current also goes through the 4 ohm resistor. It reaches this junction here, let's say that's junction A, then divides up, goes through the 3 ohm and goes through this other combination, the 2, and then divides up again. So if it goes through the 2 and the 6 and 12 will add up here. So this one at through 3 goes up, combines with this, and then they come back here. So if the total current coming from the battery is I, the current going through the 1 ohm up here is also going to be I. The total current coming out will be the total current going in because the charge is conserved. We also remember that if resistors are in parallel, then the total resistance between them is R1 dot R2 over R1 plus R2. So we start from anywhere we wish, but in this case we can start with the parallel combination of the 6 and 12 ohm resistor. So the 6 and 12, these ones here, there is total resistance between them is going to be 6 multiplied by 12 over 6 plus 12. If you use your calculator, you're going to get 4 ohm. So that means the 6 and the 12 combined, because they are in parallel, they give a resistor of 4 ohm. So now that means we no longer have 2 resistors, but we have 1 ohm. And then that 1 ohm resistor is going to be in series with the 2 ohm resistor. So in this case, we shall remove all of them, the 2, and have 1 resistor in green, which is 4 ohm. So you can clearly see that this green resistor is in series with the 2 ohm resistor. So when those two are combined, we know that for series connection, R effective is equal to R1 plus R2, which means that the 2 ohm plus this is going to be equal to 2 ohm plus the 4 ohm, and that is going to give you 6 ohm. So here we shall have instead of the 6, 12 and 2, we have only 6 ohm resistor. So okay, then you can see that the 6 ohm resistor, 6 ohm is in parallel with the 3 ohm. So 6 ohm parallel with 3 ohm. So if they are in parallel with 3 ohm, you clearly see that their effective resistance is going to be 6.3 over 6 plus 3. So 6.3, you can see it's going to be 6 multiplied by 3 divided by 9. That gives you 2 ohm. 2 ohm. So meaning that from where? From in this whole ring, we have all of them combined, they give only 2 ohm resistor. So that means now all the resistors that we have are in series. All of them are going to be in series. So we shall find out the total resistance in the circuit, R total, which is the same as the summation of all resistors. It would be, you can start with the internal resistance of the battery, which is 1 plus, the next one is 4 ohm plus, the combination of all those which were in parallel has been 2 plus, the other one, the 1 ohm resistor up here is 1. So let's add 1 plus 4, 5, then plus 2, that's 7 plus 1, that is 8 ohm. So remember, that's not what we are looking for. We are looking for the PD across the 3 ohm resistor. So PD across 3 ohm resistor, we can first find the current. So let's first find the total current, I total, which is EMF divided by the total resistance in the circuit. EMF of the battery is given as 8 divided by total resistance, which is 8. That gives 1 ampere. So it's going to be 1 ampere that is flowing through the circuit total as the total current. That current I total is the one represented as I on the diagram, as I explained before. So now we are going to see that we are going to remember that resistors in parallel, all of them have the same EMF across them. So I can remove some parts here so that I can give more explanation. Okay, I'll remove this. So you can see that these resistors in the ring, this one in the ring, all of them combined, they are in parallel with 3 ohm resistor. So that means all these resistors in the ring, the PD across them combined is equal to the PD across the 3 ohm resistor, because they are in parallel. So what we have to do is to simply find the PD across the 1, PD across the 4, PD across the R, then we add them, minus the PD, the total EMF, subtract the total PD across 1, across R, across 4. The remaining will be the PD across the 3 ohm, which will be the same PD across all the resistors in the ring combined. Okay, so let's see the PD across R, which is the internal resistance, is going to be I times R. So that is going to be I, the total current through the internal resistance, is the total current in the circuit, which is 1, multiplied by the resistance of internal resistance, which is 1, so that is 1 volt. The PD across the 1 ohm resistor is going to be I. Remember that resistor also, current going through it is 1 ampere. So that's going to be 1 times the resistance, which is 1, that gives 1 volt. The PD across the 4 ohm is going to be the resistance, which is 4, times the current, which is 1, that is going to be 4 volts. So we have all those 3 resistors. So let's add. So let's say that the voltage across them is V0. When we add, we shall have 1 plus 1, 2 plus 4, that is 6. So that is 6 volts. So the PD across all of them is 6 volts. What is the remaining voltage? We would say now the PD across the 3 ohm is going to be equal to the EMF of the battery minus the PD V0, which is the summation of all those PDs as I showed you. That's going to be 8 minus 6, which is going to be 2 volts. So the PD across the 3 ohm resistor is going to be 2 volts, because if you add the PD across the 1 plus the PD across the internal resistance plus the PD across the 4, you get 6. And now the remaining PD is 2 volts. That means the 2 volts are distributed on the parallel combination, which is 3, and then all the resistors in the ring. Okay, so the exercise that you have is calculate the total current in the circuit and the PD across the 350 ohm resistor. We have a circuit here, and in this circuit the EMF of the battery is 24. So I can give you a Q. Here we have a positive, and that's a negative. Current will come through the positive, goes like this to the left, reaches this junction, let's say that's junction A, will divide up to the left, to the right. Current going through the R1 will continue, then bend to the right. Current through R2 will continue, bend to the left, then they reach junction B. Since they are all coming towards junction B, they will add up and form another current that comes down. Let's say that's junction C. At junction C, the currents will divide up. So since this division of current, it means that R1 and R2 are in parallel. So you can deal with it using the combination R equals to R1 dot R2 over R1 plus R2. Also, there's division of current, so that means R3 and R4 are in parallel. Then use the same formula, find the combination of the resistance. So again, when you combine these ones, that means you're going to have only one resistor, and then combine R3 and R4, you also have one resistor connected like this. So let's say that is R prime and that is R prime prime. So R prime and R prime prime are going to be in series all of them. So add them, get the total resistance, then get the total current in the circuit, which is always EMF over the R total. So after getting the total current, when you multiply the total current, so for example, if you want to get V across R prime, is going to be the same as I times R prime. And if you want to get the PD across R prime prime, is going to be I times R prime prime, R prime prime. So the PD V R prime prime is the total PD across R3 and R4. So since R3 and R4 are in the same, are in parallel connection, it means they have the same PD across them, and that is the PDR VR prime prime. If you want, you can call this as the same as V of across the 350 ohm resistor.